Hi everybody and welcome to this webinar where today we're going to be showing you the latest from Trimble for Estimodeling your steel project. Now if you're not familiar with the term Estimodeling, what we're talking about is quickly creating a model to generate highly accurate material quantities and detailed labor and cost data for project estimating. Now this of course is going to help you win more bids and make each job more profitable. My name is Dave Hideman. I'm the applications specialist for the steel segment for Tekla Structures software here at Trimble. And today I'm joined by Chris Randolph, an integration specialist for Fabsuite software, who just became part of the Trimble family a few months ago. Also joining us today is Vince Hughes from Steel Estimating Solutions to show us how the Estimodeling information from Tekla Structures can be utilized in his Steel Erection Bid Wizard software. So to begin, we're going to start off by showing you Chris's screen where he can briefly give us an overview of what we're trying to achieve, the intelligent data and fabrication estimate you end up with. Then we're going to take a step back to show you the actual workflow to see how easy it is to create that information in Tekla Structures and then what we can do with the information from a truly constructible model. Finally, the erection costs are an extremely important part of a project, so we're going to go ahead and show how to utilize the Tekla model in the Steel Erection Bid Wizard to generate erection estimates. So during this webinar, feel free to type in any questions there in the chat window. We're going to be typing back responses as we go. If we don't get to your question, we will follow up with you after the webinar is over. So Chris, show us real quick what we're trying to get here.
One of our goals for this presentation is to look at how we can bring data from a Tekla model into Fabsuite, and then use that model to interact with Fabsuite, and to use Fabsuite to interact with the model. We'll demonstrate how the model can make the estimating process more efficient and more accurate with an Estimodeling workflow.
Thanks, Chris. Well, now that we've seen what we can do with the information from a Tekla Structures model, let's take a step back and see how we get that information into the model in the first place. Now, these tools are something we've been showing for several years, and they keep getting better with every new iteration, so now it's just a great opportunity to refresh yourself with how you can take advantage of this great workflow. Now, the main idea with Estimodeling is rather than writing down or typing out lines of information, you're quickly creating a virtual version of the building, which then generates all of that data automatically that can be fed into programs like Fabsuite or the Steel Erection Bid Wizard. Now, this model can even be used for things downstream from that, including passing to a detailer once you've been awarded the job. This gives you a head start on already tight schedules. So what I'm in right now is a version of Tekla called the CM license, or the Construction Modeling License. Now these tools are going to be there for any license of Tekla that can do modeling, but this is one that's specifically geared towards people like estimators. Now what you start with is this grid system, and to modify the grid you just double click on it and you would come in here and type in the dimensions that you find on your designs, including things like top of steel elevation. Once you modify this, basically what you're going to get is the revised grid, matching those numbers. So this can be used for a couple of different things. One, you can snap to it to place things like columns and beams, and two, it allows you to create views automatically based off this grid system. So I'm going to cheat here a little bit, and I'm going to go ahead and pull up a grid that I already have saved, just in the interest of saving time and getting to the good stuff. So let me pull in this grid here real quick and go ahead and create views based off of this. So like I said, this allows me to open up like a plan at a certain level, or say an elevation along a specific grid line for making bracing. And those 2D views are sometimes easier for especially new users to the software to work in those rather than try to work in a 3D space. But if I want to start, what you essentially do is create parts to match the design drawing. So what I can do is say, all right, here I've got a W10 by 60. The top of steel for this particular column is 46'9", and the bottom of the column, or the bottom of base plate, is minus 18 inches. We can do things like change the rotation to match the designs, and then you just point and shoot. And every time you click, you get an object that has all the information about this particular part, things like weight and surface area, center of gravity if you were planning on using this model for erecting. So there's quite a lot that can be done with this. So let me just model in a few more columns, because this is really what the process would look like. You type in your information, you pick a part, You type in a little bit different information, and you go ahead and create another part. Now notice I put in this column at the wrong rotation, so something that I can do is simply pull up this mini flywheel and rotate it into the proper position. Or I could have done this over here in the main properties window. So there's plenty of different tools to interact with this model. Like I said, as I create each part, everything I need to know about this part is instantly here. How much does it weigh? What's its surface area? We need to calculate how much paint is on this job. So by creating the physical objects, you're getting the physical information of these pieces. But we do have a faster method. That's kind of the basics. You recreate what you see on the design drawings. But mentioning the designs, you can actually import those right here into your Tekla model. We have a feature that allows you to import the PDF document that you're using. If you know the scale, you can set the scale. If you don't know the scale, you can just leave it at 1. I'm choosing a particular page right now that I'm trying to insert. And then I'm going to go ahead and click. And what we get is that document, that 24 by 36 inch sheet of paper, whatever it happens to be, laid right down here into Tekla model space. Now we do have separate tools to scale this thing up. One of them is just an app that's available from our website. What you do is you find this PDF and you find one known dimension. So here I've got this grid line 5 to 6 is 30 feet. I pick on the line. I can go ahead and turn on some of my snaps here. Pick 2 points. And then what Tekla will do, or specifically what this tool will ask me to do, is tell it how far that's actually supposed to be. So I'll say, okay, that's supposed to be 30 feet. And what I get is, let me go ahead and zoom all here, is I get that drawing blown up to the full size, full scale. So it's literally laying in that drawing at a 1-to-1 scale now into my model space. And because this is now a physical thing in the model, that means that I can do a lot of cool stuff with it. I can move it around. I can rotate it if need be. I can even change its elevation. So that's what I'm going to do here. I'm going to go ahead and pull in. Let's see, this is grid line 7, so make sure I'm looking at the right grid line here. And we'll place this up at the 31 foot 5.5 elevation. So by doing that, now I've got that PDF laid up at the right elevation in space. And at this point, this turns into more of a traditional takeoff. What I'm doing is I'm tracing the objects in the PDF. If I'm thinking of this in more classic terms, I would say that I was highlighting these with a highlighter. So I'm typing in information. Here I have a 24 by 55. I type in 24 by 55 into the beam tool, and then I just pick 2 points to draw that part. And I would try, the way I would do things is try to repeat that particular beam size as many times as you can. So if I have a bunch of 24 by 55s here, I'll get all those out, and then I'll change the size for whatever I need next. So 24 by 94 maybe. Now all of these I'm going column to column, and that's not always possible. So what we have as well is this tool called Snap to Line. Snap to Line allows me to hammer in these beams really quickly just by highlighting the entire line with a single click. So if I have some 12 by 19s, I can put those in. Let me just see, make sure I get all of these. So you can see how quick this is, how easily I'm able to create this information in the Tekla model. Now right now all of these parts are not coming out to the center lines, but what we can do is open up some extend tools. I can stretch these members out. So anyone who's used any type of CAD software in the past would be very familiar with this type of feel for these particular tools. So real quick, it allows me to stretch these guys out and get them to their true length. That way we're getting a much better idea of the size of these actual members in the real world. I can see there I missed one of those little W8 by 10s. So let me go ahead and throw that guy in real quick. Nope, I already got that highlighted. And we'll extend you as well. Alright, so once you get those members in, as you're building this model, you're building a database of information. So if I wanted to at any time generate some type of material list, like we're not even getting to the Fabsuite side and that cool stuff yet, I could run a report like this material list just to get a rough count of my material and what we've created so far. And that easily I'm able to generate this list because I highlighted or I traced what we saw in the drawing. But there is a better way. So this method allows you to import the design drawings right into your Tekla model space. But what if you're able to get a 3D model from someone? IFC is a standard format that we can read and write along with engineering softwares and architectural softwares. So this common language, this IFC file, we can actually import to build your model for you. If I go to my reference models, I'm going to go ahead and pull in one that I've got set aside here in the model folder, just called sample IFC. When you add an IFC model, initially it comes in as a big chunk. It's coming in from an external source. It's just pasted in as a reference. But the cool thing about this is because we know, because of this common language, we know what the sizes are of these members. We have a converter. And what this converter does is it looks at the size and shape under the hood and it says, okay, you were originally designed in the source software, wherever it was you came from, you were designed as a specific size, in this case a W10 by 12. Well, what do you know? We have a W10 by 12 in our shape catalog as well, so this feature builds the model for you. So that quickly now I've got the entire stick model created based off of the IFC simply by 2 steps: import, convert. And now I could run that material list again with a much more complete list of material. Now we're just talking about a simple takeoff at this point. Your estimate contains a lot more information than just a takeoff. You also have things like connections, you've got bolts, you've got copes, you've got welds, right? So if we want to include that information, the fastest thing we can do is also include it in the Tekla model. Now we've got a series of connections like this guy. This is a clip angle connection, and when I put it in one at a time, it's going to include my bolts, my welds, my copes, all of the information we need to know how to fabricate that beam or the entire connection really. For a detailer, this is pretty standard operating procedure, creating these things. But from an estimate standpoint, this is not how I really want to work. I don't want to be going through the model going pick, 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 and choosing the right connection. So in that case, what we have is a tool called Autoconnection. And Autoconnection is exactly what its name implies. I can run Autoconnection. I can choose a specific connection type. In this case, I'm doing shear tabs. By the way, if you look for a second here, you can see I've got clip angles. I've got a setting called fittings prelim, which simply does cutbacks to the face. So we do have some other options in here, and just like everything else in Tekla, it's totally customizable. So I'm going to go ahead here and hit Create Connections, and we'll see that anywhere I have steel that hits steel, I have a joint that's now created. And that's more information about bolts and welds and plates and all that stuff that's eventually going to get fed into Fabsuite, as we've seen. Now, if you're looking for something a little bit more detailed, I'm kind of sidetracking a little bit here away from the traditional Tekla method of estimating, but there are some really cool partner products that can also give you those connections, but give you fully designed connections. So you're not just guessing what you're going to get. You can really get the nitty-gritty of exactly what this connection is going to take. And one of those programs is this software called Connect. And hopefully you guys are already familiar with Connect. We show this all the time. We love this software. But just to give you a quick recap on a small portion of this particular building here, I'm going to highlight this section and I'm going to run their export. Now what this export does is it doesn't actually take your model. It takes the model information. It takes the geometry, the length, and the sizes and that kind of information, and it sends it up to their cloud. So we'll just call this our estimating example. And I'm only doing this for a small portion of the model in the interest of saving time. Now I could run this for the whole thing. One of the times I ran it on this model for the entire thing, it connected the entire project in a little over 2 minutes. 2 minutes of me just sitting here and you staring at the screen is a little awkward, so we're going to go ahead and just do it on a small portion of the model just to serve as an example. But what happens is it takes that geometry that I was mentioning and it sends it up to their cloud servers, which does the actual engineering and the design of these end connections. And what you'll get is an email telling you, hey, we're done, we've calculated the results for X number of connections, and then you can run this number 2, the import function for Connect. You can see here that it's already showing the estimating example is ready, so I'll hit submit, and it's going to import that information and not just, apply a connection like I was doing with Autoconnection, but it's a fully developed connection. So if I double click on one of these and open this window a little larger, we can see here's all the calcs for that particular joint. So it's as fast as the Autoconnection that Tekla has built in, but it is a huge amount of data. It's so much more realistic to what you're really going to need to do for those particular joints. So that's just one option. It's obviously not something that's required for Estimodeling in Tekla, but if you want to have some better data, it's a pretty powerful tool. So let me go ahead and I'm just going to run auto connection on the rest of this. Again, in the interest of saving time, I'm just going to run my basic shear tabs. And after a moment, it's gone ahead and created all of those connections for me. So now my entire model has been auto-connected, and while they may not be perfect, they may not be exactly what I'm looking for, it's going to be good enough for me to get that estimate, including things like bracing. I could run base plates on these, although I haven't done so yet. Another thing that's often part of an estimate that people don't realize they can quickly do in Tekla is things like your miscellaneous steel. So just to really quickly show you what the miscellaneous can look like in Tekla, I'm going to go ahead and flip here to a plan view, and I'm going to cut just a temporary view for like a stair opening. So what I'm going to do is cut a view using 2 points, not using my designs here. I'm just kind of being a little bit quick and dirty about this. And now what I can do is use our components to mock up a quick stair. If I go ahead and measure this, let me check my numbers. Looks like from floor to floor here, it's currently 8'4 1/4. So I'm going to use a stair layout tool. Again, I'm getting maybe a little bit too detailed with this, but let's say that the top of our concrete is 8'8 1/4. We're going to have 4 inches of concrete here. Offset this by 6. And then what we can do is use this cool layout tool to create a quick construction line that's going to be basically the slope of our stair. That's the nosing line for my stair section that I'm about to include. We can quickly pull up a stair. I'm pulling up this Z-pan option. I'm going to go ahead and change a couple of settings here so that I'm framing to a landing beam at the top. And then you go ahead and pick your points. I'm going to pick the insertion points, pick on the beam I'm trying to frame to, and middle mouse click to get my stair. So if we go back now to my 3D view, now I don't just have my structural items, but I've also got my miscellaneous items in here as well. And we could go to a lot more detail on this. We could actually fully detail out this stair, but again, with an estimate, that's not always really what we need. That's not what we're trying for here. But just to also show, if you needed to, you could very quickly throw in something like a picket rail. Just by picking 2 points, selecting the objects that I'm trying to connect to, and that quickly I can, again, create, just for estimate purposes, I can create a quick handrail. So there's a lot of tools available here to show all of the information in the model as much as you want. If you wanted to show things like pour stops, we've got things for pour stops. If I wanted to run this quick pour stop applicator, I could pick around the perimeter of the building, create my pour stops there real quick, and this has been set up to do, I believe, 5-foot maximum lengths for my bent plate. So literally like everything in the model that you want to create. Embeds, that could be bearing plates, that could be embed angles, miscellaneous steel like I've shown, bracing connections, moment connections, even down to the backer bars, and I mean everything that you might need, if you want, you can include it in the Tekla model. So let's show now how you get that information from Tekla into Fabsuite so that Chris can show you in more detail what that process looks like. What you would do is come up here and go to File, you would go to Export, and then I would choose IFC. So we have a customized IFC export specifically for sending to Fabsuite to make sure that we get them all of the information that they need. This will be downloadable from the warehouse. So I'm going to load that Fabsuite setting and hit export, and it's going to generate the entire model for me. So now I have that IFC file that's created in my model folder. All you need to do is send that over to Fabsuite. So I'm going to switch over to Chris now, and he can show you how he imports that file and then what that whole process looks like.
Now I'm going to start by importing the data from the IFC model that we've gotten from Tekla. If you're a Fabsuite user, in the past you may have used the KISS format if you had a model. More than likely, though, you just use the tools that are in Fabsuite's estimating module. If you didn't use Fabsuite for your estimating, you may have done a takeoff on paper or in a spreadsheet. The advantage of using the IFC over the KISS file right now is the inclusion of the unique identifiers that are called GUIDs that let Fabsuite connect to each individual item in the model. The KISS file doesn't have that. For the future, IFC is going to have more advantages as the information that can be included in the IFC can evolve with our needs and with your needs over time. In the Estimating Job Edit window, you can set up information that's specifically for this project. In addition to that, you'll have others set up in Fabsuite that's for your shop in general. Fabsuite does a great job of giving you some feedback on the import. If it has items that it doesn't know what to do with on import, it'll summarize those in this import log. Or you can see more details by clicking this Open Import Log button. You see here we have some concrete pads that Fabsuite ignores. Before we go into our estimate, I'm going to select this estimate job. I'm going to attach our model to it. Now we'll open our estimating job. From the IFC file we imported, we got all this material information. The M notates our main material. We have our submaterials. Our bolts are listed as line items. Note at the bottom right, our additional labor window that shows our welds and our punches. And at the top, we have our labor summary. We can also view more details on that to see where our labor calculations are coming from. All this can be set up in Fabsuite specifically for how your shop works. Just for an example, I'll come in and I'll make some minor edits here. Pay attention, when I commit this change, pay attention to the labor summary up here. So I'm going to add some more punches to this piece. I edit that. When I commit that change, my calculations up here change. Same thing with the welds. If I edit that weld, when I commit that change, my calculations up here adjust. In a typical workflow in Fabsuite, you're going to concentrate on using these labor types to apply labor to your materials. Because we're getting a lot of that from the model, we're just assigning on import a standard labor type of A for every material. What that labor code does by default is apply labor for unloading, getting the piece, cutting the piece, painting, loading it back up on a truck. Another item for other, for moving the material around. That's by default. If you had a different labor code, say you have welded clips on both ends, we're going to add labor for those clips, labor for those welds. And in a traditional workflow in Fabsuite, that's what you would do. However, because we have this additional labor that's coming in from that model with your punches and your welds, we have your clip angles in your material list. We're saving you a lot of work here, creating your estimate. All that labor has already been accounted for by bringing in that model, that IFC model from Tekla. The other way using that model can be really powerful in Fabsuite is through our Fabsuite View model interface. Of course, that's going to open up on my other monitor, but I'll bring that over for you. What this Fabsuite View interface lets you do is interact between Fabsuite and the model directly and live. So I can select any item in Fabsuite and select that item in the model. Vice versa, I can select items in the model and select those items from the model in Fabsuite. That allows me to use tools such as Global Edit in Fabsuite to edit many items at once based on that selection in the model. So let's say you prefer not to put your column base plates in your estimating model, but you want to apply labor codes for those base plates in Fabsuite. So what we could do, we could change our view to where we can see all your columns. And we'll come over here, we'll hide parts that are not in Fabsuite so we can get rid of those concrete pads. We'll select our columns. Now in Fabsuite, we will select from the model. We'll do a global edit. Change that to a labor code for a welded base plate. There you go. I can also enable auto select in the model so that anything I click in Fabsuite is selected and zoomed in the model. I can isolate that item. Or I can enable auto select from the model so that anything I select in the model is selected in Fabsuite. We also have these status options in the model viewer. We can colorize by whatever items have status in Fabsuite. Of course, the final step in preparing your estimate is getting your reports. And Fabsuite is loaded with reports. I'll just show you a couple of examples where you can pull data out of Fabsuite to use in assembling your final estimate. Because we're pulling items like bolts and washers as line items instead of as part of our labor codes in this case, I want to use a summary that's going to include shapes. So I have a more complete summary of each line item. As you can see here, we have several reports built into the software, well formatted, well thought out, to help you get your estimate out to your client.
Thanks for that, Chris. So we've seen how creating the Tekla model, creating the IFC, feeding that data into Fabsuite allows you to automate so much of the fabrication estimating process. We also mentioned being able to use the Tekla model for your erection estimates. And in this case, we're going to be showing you that workflow using the Steel Erection Bid Wizard software. So let me go ahead and generate the file using our extension, and I'm going to send that over to Vince, and then he can show us how that software works. So the Steel Erection Bid Wizard export is available on the Tekla warehouse. It's going to get added to your applications and components catalog. If I do a search here in the catalog, there's my export to Bid Wizard. I'm going to double click to go ahead and launch this. And essentially what we have is a series of selection filters and then a series of Bid Wizard categories that link a part to a category. These can be customized. We do give you some presets. I'm going to go ahead and just say apply to all. And what it's going to do is scan through the model using those filters, and it's going to tag them with a user-defined attribute that will be included in a report. Now that that's complete, I'm going to go ahead and open the reports dialog. And as part of the extension install, there is a Steel Erection Bid Wizard CSV file. Here's the spreadsheet, including the information with my quantities. All right, so now I'm going to go ahead and give the screen to Vince from Steel Estimating Solutions, showing us the Steel Erection Bid Wizard software and what he can do with this bit of information.
Thanks for sending that file over, Dave. I tell you, I'm really excited to see how far Estimodeling has come over the last several years. I remember back early 2000, I teamed up with a design build fabricator. He would serve me the model on some select projects, and I would take that model and share it with my crew to kind of get a game plan of what we're erecting. Made it real easy to visualize what we were doing. I remember thinking back then how awesome it'd be to be able to have a system where I could take the data from that model, upload it, and get my erection price. Really excited to be able to say that today that's a reality with the integration between Tekla and Steel Erection Bid Wizard. It's going to make a really good tool for where it's a fabricator that's wanting to check erection prices that are coming in, or a fabricator erector that of course wants to get his erection price, or an erector that can get access to a model will be able to get his erection price in a very quick fashion. And with that said, let me just show you how quick it really is to be able to generate that erection price. Just simply, we're going to navigate to that file that Dave sent me from the model. We'll select the app that we're using, import it. It's going to tell me the quantities were successfully imported. I'll delete the 0 task to clean up the list. And now we're going to see where all the beams have come in, the columns, brace frames, joists, angle, deck, and the stair flight. And keep in mind that David, modeled the main structural components, did throw some perimeter angle and one stair flight, but that model can be taken as far as you want. Everything that's in that model can be brought into the Steel Erection Bid Wizard for your erection price. And also, this price is going to be based on tried and true production rates for labor, crane, and weld time, based on a professional crew of ironworkers installing the task, as well as industry standard crew sizes. You do have the ability as a user to change these production rates to fit your company, but right out of the box, they're tried and true. So we'll come back up to the top. We're going to throw in average crew size, 5-6 men. I'm going to plug in 6. Select the wage rate for the area that project's going to be in. Come and add some equipment. Grab a forklift, some boom lifts. All this equipment's already defaulted into the system. Of course, you can add more, change what's there. You know, it's entirely up to you. I'll grab a crane. And in general conditions, let's grab some safety cable real quick, just to plug it in. I'm gonna have to supply some cable that we're gonna install. And then I want to talk real quick about a new enhancement, Smart Fuel Calculator. Smart Fuel Calculator, all this equipment that's in the system, I went and got the manufacturer's burn fuel rate per hour. And the system's going to calculate exact usage for how long we're going to be on that project for the per day for each piece of equipment. Give me a total dollar amount per day and then total it up and add it for the full project. We all know how fuel's kind of a hidden cost and kind of always, it adds up. With the Steel Erection Bid Wizard, you're going to be able to dial in exactly how much fuel you're going to use for each piece of equipment throughout the project. Another new enhancement I want to point out too is weather projection. For us, it's always a challenge. Our guys would go out to the job site. If they got rained out or whatever it may be, I had to pay them 2 hours show up time. So this new feature here will kind of look at that and makes it pretty simple to figure out how weather is going to affect the project. If you know the start date, you're going to plug that in that the general contractor gives you, or you kind of got to guess it's going to be 3 or 4 months out. You select the start date. System knows the end date because it builds us a schedule. We come in, select the state we're working in. At that point, it's going to go into weatherbase.com, who has tracked historical data for 30 years and is going to give us an average percentage of average lost days, and is going to calculate that into the bid. I can use that as knowledge, or I can use the dollar amount to my bid. Entirely up to you. Then at that point, we'd come and we'd massage it for profit and overhead for labor, equipment, crane, general conditions, or by fuel, which just allows you kind of massage that bid. And at that point, now we have our erection price in a very quick fashion, as I had mentioned earlier. Also, not only that, we're also going to have a schedule. Just show you kind of what that looks like. It's a duration schedule, so the idea behind it is to be able to give this to the general contractor, who then builds the schedule we got to live by. Of course, we want to give them we wouldn't want to give them our dead nuts days. We want to pad it a little bit. So once I give myself a few extra days, I'll hit save, and then I'll show you what this schedule looks like that you can print out, give the general contractor. Basically, like I say, it is a duration schedule, gets built for you. Automation makes it very simple to get a schedule to a general contractor for durations. And with that said, Dave, there's an erection price based on the model that you sent me in a very, very quick fashion. I do appreciate the opportunity to show the integration here with the Steel Erection Bid Wizard, and I'm going to hand it back to you.
All right, thanks, Vince. And thanks again to Chris for showing us Fabsuite earlier. So hopefully you got you guys excited about the possibilities of what can be done when you start Estimodeling with Trimble, whether you're a fabricator, whether you're an erector, or another contractor on a steel project. Maybe we help get some wheels turning about some other ideas on how you can implement some of these tools. So we're going to wrap it up here. If you've submitted any questions that were not answered in the chat, we still have those recorded, so we're going to go ahead and follow up with you guys later. Feel free to reach out to us with any additional questions. Our email addresses are there on the screen. And thank you everybody for joining us today.